This lesson is going to go through the periodic properties. So first I want to talk a little bit more about how the periodic table is arranged. So the periodic table is arranged into periods and groups. Periods are the rows. Elements in the same period have the same number of electron shells. So if we were to look at elements in period 2, they would have 2 electron shells. And we can see this if we were to draw out our Bohr diagrams. So let's say the first one we were going to do was lithium. Lithium is in the second period. That means it has 2 electron shells. A lithium atom would have 3 electrons, so it has 2 electron shells. We could also look at a Bohr diagram of oxygen. So oxygen is also in the second energy level. It has 8 protons, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So we see that both of our atoms in period 2 have 2 energy levels. And we have our nucleus in the middle. We are also going to look at the groups of the periodic table. So periods are the horizontal rows, whereas groups are those vertical columns. So elements in the same period have the same number of electron shells. Elements in the same group have the same number of valence electrons. Remember, valence electrons are the electrons in the outermost energy level. So if we look at elements from group 1, group 1 elements have 1 valence electron. So we're going to draw Bohr diagrams for lithium and sodium. Lithium and sodium are both in group 1. So lithium is in period 2. It has 1 2 electron shells, but it's in group 1, so it has 1 valence electron. Sodium is in period 3. That means it has 1, 2, 3 electron shells. Sodium is atomic number 11. 2, 4, 6, 8, 10, 11. So elements in the same group are going to have the same number of valence electrons. Really important to note. Elements in the same group have the most similar properties. So the number of valence electrons affect how atoms bond, and the way that an atom bonds then determines its properties. So elements that have similar number of valence electrons bond in the same way, they are going to have the same properties. So a few important groups to know on our periodic table. So group 1A, we call the alkali metals. This does not include hydrogen because hydrogen is not a metal. We call group 2 the alkaline earth metals. Group 7A are the halogens, and we already know group 8A are the noble gases. I have my periodic table color-coded, and we're going to talk about these elements next. So everything in this greenish blue color, which is most of the elements on our periodic table, those are all metals. Purple, these are the metalloids. Metalloids are the elements that touch what we call the staircase. So if you look on your periodic table, we have this darkened line that kind of looks like a staircase going down. Every element that touches the staircase except for aluminum is considered a metalloid. Everything to the right of the metalloids plus hydrogen is considered a non-metal. So let's talk about some properties. Metals. They are good conductors of heat and electricity. So that you should be familiar with. Metals get hot. They are good conductors of heat and electricity. Metals are lustrous, or they have luster, which is just a fancy way of saying metals are shiny. Again, something you should be familiar with. We know metals are shiny. Metals are very dense. Metals are also malleable. What this means is that metals can be hammered into a sheet. I always remember malleable like moldable. Metals can be moldable. If you had a metal that was spherical, you can hammer it flat. Metals are also ductile. This means they can be drawn into a wire. So think about like a spool of copper wire. Metals can be drawn into a wire, and we call that property ductile. Those are the general properties of metals. You should be able to distinguish the difference between our group 1 alkali metals and group 2. The group 1 metals are going to be very soft. The group 1 metals you can very easily cut with like a spatula or a scoopula, and they're going to be very soft. They're going to, in general, have a silvery color. They are very reactive with water. So I have a demo of testing 3 group 1 metals, lithium, sodium, and potassium, and you guys can watch that to see how reactive these metals are with water. In general, metals have a really high melting point, but in comparison, the group 1 metals are lower. So they have a lower melting point compared to other metals. So how do the group 2 metals differ? So these are still going to be silvery, but maybe more of like a silvery white color. Fairly reactive, but less reactive than group 1. All right, let's move on to nonmetals. Nonmetals have all opposite properties than metals. So metals are good conductors of heat and electricity. Nonmetals are poor conductors. Metals are shiny. Nonmetals are dull. Metals are malleable. Nonmetals are not. So if we had a metal and we were to hammer it, we can flatten it into a sheet. If we had a nonmetal and we hammered it, it was going to break into a bunch of pieces because nonmetals are very brittle. Metals are ductile. Nonmetals are not. A special group of nonmetals are in group 7. Those are the halogens. That word halogen just means salt producing. The halogens are going to be very reactive with group 1 metals. So an example, one of our halogens is chlorine. Group 7 halogens are really reactive with group 1 metals. like sodium. So sodium and chlorine can react to form sodium chloride, which is table salt. We also labeled the noble gases, which are in group 8. The noble gases are unreactive, or we call them inert. The reason why they are unreactive is because they have a full outer shell of valence electrons, which is 8. Remember the octet rule. 8 is the magic number. So we know that atoms want to ionize, they want to gain or lose electrons in order to have 8 valence electrons. So sodium reacts by losing an electron, so it has 8 valence electrons. Chlorine has 7 valence electrons. It reacts by gaining 1 electron to have 8. Well, the noble gases already have 8 valence electrons. Since they already have 8 valence electrons, they're not going to gain or lose any electrons, which means they are going to be unreactive. All right, we talked about metals. We talked about nonmetals. Last up are those elements on the staircase, which we call the metalloids. The metalloids are in between the metals and nonmetals. That means they're going to have properties of both. Metalloids share properties with both metals and nonmetals. So maybe you have an element that is conductive, like a metal, but it is dull, like a nonmetal. If it has properties of both, we would call that a metalloid. Metalloids are often called semiconductors. Again, because they're right in the middle of those metals and nonmetals, so they are going to have properties of both.